In this video, we're going to talk about how to classify matter and the different types of matter that we see every day. So think about the discovery activity that you did. You classified matter a couple different ways. In part A, when you were dealing with the oobleck, that cornstarch and water, you were trying to figure out if it was a solid or a liquid. So one way you were trying to classify matter was by states. So states of matter. Was it a solid, was it a liquid, or is it a gas? The other way that you looked in the discovery was you looked to see if white solids dissolved in water. So dissolving in water is another possible way that we can classify matter, and that's called solubility. What we're going to do now is we're going to actually look at this flow chart that deals with matter. So matter is all the way up here at the top. Matter is everything. Anything that has mass and takes up space is matter. Okay? Everything is matter, anything that has mass and takes up space. So everything is either an element, a compound, or a mixture. So what we're going to do first is we're going to talk about the left side of this flow chart, which deals with pure substances. So pure substances have definite composition, and it's either a single element or a single compound. That's a pure substance, so it's just one thing. Maybe it's salt, table salt. Maybe it's gold. Okay? Pure substances deal with being chemically combined. We use the periodic table for pure substances. So pure substances can be broken down even further into elements, like from the periodic table, so gold, silver, sodium, anything that you can find directly in one of the boxes on the periodic table. The other pure substance that we can have is a compound. Okay? And a compound is a combination, a chemical combination, so it has to be bonded, so elements bonded together is a compound. Then the other side is we have a mixture. So a mixture is a physical blend of two or more substances. So it's a physical blend, so you're mixing things together. Like sand and salt, you mix together, that's a mixture. Mixtures can be broken down into heterogeneous and homogeneous mixtures. And we're going to talk about the differences between these two. So this is matter, this is how matter can be broken down, and we're just breaking it down further and further. So let's think about pure substances. So again, a pure substance is a single element or single compound. So if we look at an element, it's one thing. It's the simplest form of matter. Okay, so sodium, we can find Na, which is sodium, in a box on the periodic table, right? One of the squares on the periodic table has Na in it. That's an element. Copper is Cu. Chlorine is Cl. Oxygen is O. Hydrogen is H. Right? Those are all elements. That's the simplest form of matter. Then we also can have a compound. So a compound is a chemical combination of two or more elements. So table salt is sodium chloride. It's NaCl. Water is H2O. Carbon dioxide is CO2. They all have chemical formulas. So pure substances have one chemical formula. Either it's an element like Na, or it's a compound like NaCl. And then compounds can actually be broken down into their elements, but in order to do that, they have to be chemically separated. So compounds have to be chemically separated into their elements. So now let's think about the right side of that flow chart, which dealt with mixtures. Now I do want to tell you that mixtures, so if we look back at this flow chart, mixtures can be separated into their pure substance. So if we have a mixture of salt and water, okay, we can separate that physically. Mixtures can be physically separated into pure substances. So remember I said a mixture is a physical blend of substances. We physically mix things together. A heterogeneous mixture looks different throughout. So an example might be vegetable soup. Okay, it's a mixture because it's a physical blend of vegetables, broth, maybe there's meat in it. That is a heterogeneous mixture because it looks different throughout. You can see the different parts of the mixture. Versus a homogeneous mixture, so hetero means different. Then we have homogeneous, which is also called a solution. That looks the same throughout. So even though it's a physical blend, like salt water, we added salt to water, but it dissolves. We can't see each individual salt crystal in the water. That's a homogeneous solution. That's going to be the difference between the heterogeneous and homogeneous mixtures, whether it looks the same throughout or whether it looks different throughout. So here's some examples. Vegetable soup is a heterogeneous mixture. Soil and water, okay, dirty water is a heterogeneous mixture. Kool-Aid is a homogeneous mixture because you can't see all of the different parts of Kool-Aid. It all just looks one color. Okay, Coca-Cola also would be a homogeneous mixture. Okay, then the next thing that we're going to look at are states of matter. So we have 3 states of matter, and you need to be able to distinguish between the 3. So we have a solid, we have a liquid, and we have a gas. So if we start by looking at the gases, these are called particle diagrams. Okay, gases are very disordered. All the particles bounce off of one another, they collide with one another. They have no shape and no volume. So what that means is when you put it into a container, it actually takes the shape and volume of the container and it fills up the space. Okay, gases have the most energy. So gases have the most energy. Then liquids. Liquids are kind of an in-between. So your particles can move past one another, but they're still pretty close together. Okay, they move around randomly. Liquids have no definite shape. So they take the shape of whatever container. So I have this water bottle and I have water in it. Okay, I have a liquid in it. The liquid in this water bottle is going to take the shape of the bottle. So whether I have it in the water bottle or whether I pour it in my coffee mug, it's going to take the shape of whatever container it's in. However, it's going to have the same volume. So it has a definite volume. So maybe I have 200 milliliters of water in here. Whether I put it in this bottle or in the coffee mug, it's still going to have 200 milliliters. Then we have a solid. In a solid, your particles are packed really close together and they just vibrate in place. Solids have a definite shape and a definite volume. So if I have this pen and I put this pen into my coffee mug, this pen is still going to have the same shape and the same volume no matter what container I put it in. So gases have the most energy, solids have the least energy.